Hello everyone. If you're watching this video, then you are looking back at week 4, day 1. Everyone was present this day, so I know you weren't absent. Good job. Way to be there. Let's talk about what we did that day. We talked about representing text, how we can represent black and white images, and color, all using binary. So the point of today was really to get an idea for how binary, just numbers, can be used to transmit various information that is visual or auditory. You should be able to describe how binary can be used to represent different kinds of information. You should be able to note what abstraction is and how metadata is included to create an image. Let's get started. So the first thing we thought about was how could you use numbers to represent basic words? And then through a series of challenges, we eventually arrived at this system right here. This is the ASCII system. It's how your computer actually stores various letters you type out. Notice that each possible letter here is exactly 1 byte of information, right? So this is 32, but we still have these 2 leading zeros. Those are important because they are included in the storage of each letter. So you can't just smush them all together and know what each letter means without the leading zeros. So unlike counting, leading zeros are important when you're storing information. Now, the next thing that followed out of this is this idea of abstraction. Abstraction is taking something that's really complicated and has lots of detail, and then removing those details from the conversation to just focus on the functionality or the higher aspects of particular application. So in this case, if I send you a text, underneath the hood, this text is being translated into ASCII, which is then again being translated to binary. We as the end user don't have to think about these two representations. They're abstracted away from us. ASCII is an abstraction of binary, which is what's actually being stored in your phone, which is again an abstraction of the actual text you see. So there are levels of abstractions going on, and we're going to keep seeing this throughout this class in many different contexts. So this is an important concept to wrap your head around early. Think about another representation of something in your everyday life that you can use without thinking about the underlying context. For instance, maybe Google Maps has 2 different views. One is the satellite view, where you can see all the various trees, dogs, people. But when you're actually driving, you don't need to look at any of that. So use the map view, where you can just see the street names. All that extra information is being abstracted away or removed from your vision, so you don't have to worry about it to drive. So that is another example of abstraction. Then we looked at black and white images. We watched this quick video, which I won't show you. We played around with a pixelation widget, which allows you to type in zeros and ones to create white and black squares on this grid, and you can create various images. Obviously, the more pixels you use, the better your image can be. We talked about ideas of resolution versus pixel density. Resolution is the literal number of lights you have on your screen. So in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is the number of lights you have up here at the top. And then 10 is the number of lights you have going down. So the total resolution will be 10 by 10. The pixel density would be how many lights you have per inch. So if I was to literally measure this screen on my ruler and see how many of these fit into an inch, I would get a very low number, something like 3. Your phone can have many, many, many bits per inch. Not bits, pixels per inch. So the higher the pixel density, the nicer and cleaner your image will look. We then went on to do an assignment, which you guys can find on MyMCPS under modules for week 4. It is titled 010801 Pixelation. If you open it up, you'll see the following. We've got 2 challenges for you to do in that pixelation widget. There's a link to the widget right here. First, I'd like you to try to make this duck using just a very small grid, and then using a higher resolution, or, well, I don't know what density you would have on your screen, but definitely a high resolution option with more pixels at play here. And I'd like you to time yourselves doing this and then describe how it went. From there, the next assignment is to make a small favicon using the colored widget. So let's take a look at the colored widget together because I think it's really cool. So the colored widget, there's a link to it right here, involves you doing the following. You can type in some metadata up here. Metadata is data about data, or something that describes the following information. In this case, the metadata describes the width, the first byte here, the height for the second byte, and the number of pixels, or rather the number of bits you're going to use per pixel inside your message. So all of this is really important to have if you're going to make sense of the following image. And you can change these values either by using these sliders or by literally altering the number here. The next thing to note is the number of bits per pixel is going to change how many colors we can have. If we just have 1 bit per pixel, well, you can either have ons or you can have offs, white or black. That's it. If we turn it up to 2, we can have shades of gray. So we can have on, but you could also have a gray as well as an off. The last thing we want to do, and probably the whole point here, is we can change it up to 3 or multiples of 3 to create, I guess not necessarily just multiples of 3, but we're going to be using 3 and also 12. 12 is how many are used in the real world, but just looking at 3 for now for simplicity's sake, what we have here are the following bits, 1 for red, 1 for green, and 1 for blue. And those bits will determine how much of each of those colors are present inside each of the little lights. So for instance, if I type in 100, I have all red, no green, and no blue. So you guys will see red. If I type in something like 010, now I'll have green. But you can also mix colors. So if I type in 110, now I have mixed red and green and created yellow. So obviously you're very limited with using just 3 bits per pixel. So if you were to turn it up and use 9, or in the real world we use 12 bits per pixel, now you can have all sorts of shades. So if I type in something like this, I can get an off shade of green that combines some blue. That's not a shade I would be able to normally get with just 3 pixels. So the more pixels, the more colors you can have. Pretty neat. All right, let's keep going here. So what's our next order of business? We're going to be sampling the image. In that first part of the assignment, the more you sample the image, the more you get closer to representing analog data, which is usually the kind of data you find in the real world, something that's very continuous or very clear or has a clear flow to it. So you can think of analog data as not being composed of a series of points, but rather being like a runner during a race. He's not pausing at any point. He's continuously moving throughout the whole race, right? So music is this way. You can't pick out a single point in music. You could pick a single note, but even that note is playing over a continual of time, and there's never a single dot of music. That doesn't make any sense. However, data inside the computer needs to be stored as a series of points using binary. So the more points we can have, the more we can make digital data, point data, look like this continuous analog data. That is the point of sampling. All right, so the color system I already talked about. You guys need to make a 16 by 16 favicon, which is just a small logo with colors, and answer those 2 questions at the bottom of the assignment. Here's a favicon I made, so hopefully yours looks better than mine, or maybe as good as mine. I don't know. Obviously, we need to be using more bits if we want our image to be more complicated and have more colors. And we're going to be looking at this layer system next time we meet. All right, I'm going to leave it there. Hopefully you guys are all set, and I'll see you guys next class.